Hello friends, welcome back to my channel Quality Magnify India. Myself Deepak Kumar Samal, welcome all of you to my channel once again. So we are continuing with APA 653 and we have completed part 11. I can say a major part of APA 653 is already completed. We have now few parts like 571, 575, 577, ASME section 5 and ASME section 9. ASME section 5, section 9, 577, 571 already I covered in APA 570 course. If you want to check those, you can check all those courses in APA 570. Out of these courses which I told to you now, I will repeat two courses 571 and 575 for APA 653. So we'll cover 571 and 575, which are the remaining slides for APA 653. In today's course, we will cover API 653 571 damage mechanism, and in another one slide, in another one video, we will cover 575 inspection. So those two parts will cover the complete APA 653 courses. As I told you, remaining courses section 5, section 9 and APA 577 welding part you can check in my 570 course. So by this we'll complete APA 653. So as you know, I have completed the series for APA 570, 510, 653, which are most important, which are most demanding courses in nowadays in the market. Beside to that, there is another one course called APA 580 RBI, Risk Based Inspections. After finish of this APA 653, I will start APA 580 series. So complete present situation or present market situations. What are the APA demand is there? You will get all the course schedules like 510, 570, 653 and 580. Why I am giving more importance to API? Because earlier in 2000 to 2005 time, there is a demand on CSWIP and Bgas, painting inspection. People are less interested in API because at that time there are less welding inspectors, painting inspectors, piping inspectors, and usually at that time for piping inspector no certification was required. Okay, they just take them as a experienced guy who work in piping industries. But as the time passed, there are more competitors, there are more candidates in the market. They start filtration of those courses, filtration of those candidates, and they try to select those candidates who have at least some CSWIP or Bgas or AWS as a base with some additional API courses. In my personal opinion, API courses are very valuable, and everybody who is in these industries, petroleum industries or pressure vessel industries or piping industries or tank manufacturing, they must acquire this knowledge, not only to get a good career but also to get a good professional knowledge. That is very much important. So friends, we'll start from part 12 APA 653. So as I told, I will start with APA 571 damage mechanism affecting fixed equipment in the refining industries. The same topic we already read it in APA 570. Why I am repeating this one? The reason behind it, APA 570 will carry minimum 10 questions. 8 to 10 questions you will get in API 653 exam. 8 to 10 question is must from APA 570. Just to recall those points, I will not go in details. There are almost 30 slides. I have put all the slides the thing behind it, why I put all the slides. You have to take note of that one and you have to do the practice. I will not take much time to complete APA 571. The intention behind it to make 571 to practice those things to revise those things which we did in APA 570 during our APA 570 course. Whatever the points we have already discussed, those points we just need to recall it, because as I told, it is very easy to score. In the last slide I put a chart where I have mentioned all these details. You can note down all those, and it is very important. You can note down from the first page whatever I am saying, find out the bullet points and keep in remembering. There is nothing brainstorming on this one. To pass the exam, you can go in detail of those things, and you can practice this. You can refer to other documents and grow your knowledge. But to pass the exam, if you highlighted the important points of APA 571, you can easily score 8 to 10 points. Okay, so let's start. Damage mechanism affecting fixed equipment in the refinery industry. What do you mean by damage mechanism? When we are installing some equipments based on the product means whatever the product is going through that piping system, that pressure vessels, okay, that equipment. So that product is maybe one factor which can damage the equipment, or the environmental condition, that is another one factor which can damage, or the outside activities which is going on with the product, that is also one of the factor, or the humidity, or the temperature, or the area where it was installed, whether the equipment was installed in a North Pole, whether it is in a Gulf industries, whether it is in African industries, whether it is in Asian industries. So depend upon the temperature, the dew point, the humidity, the environmental condition, the product we use, based on that the equipment can be damaged. So we have to find out the possible damage which is expected for that equipment. Based on these conditions, what are the damage mechanism can happen to the refining industries. So as we know, before we start, we have to terms and definitions we have to just to follow. What is austenitic stainless steel? Austenitic stainless steel is commonly include the 300 series, 304, 304L, 304H. All these are related to austenitic stainless steel industry steels. Okay, the L and H suffix refer to the control range of low and high carbon content. If it is 304L, then 304L denotes for low carbon. Okay, and H for high carbon. Where there is H, that is high carbon. Where there is L, that is low carbon. Duplex stainless steel, a family of stainless steel that contains a mixed austenitic ferrite structural including Alloy 2205, 2305, 04, 2507. This is called duplex. If you want to know more about the stainless steel, I have a separate video for stainless steel. You can go there and watch what are the types of stainless steel, what is duplex, what is super duplex, what is austenitic, what is ferritic, what is martensitic, all these stainless steel details, it is there in that video. So you can visit that video and you can watch all those about stainless steels. So ferritic stainless steels, this is 400 series, 405, 409, 430, 442 and 446. High strength low alloy steel, a family of carbon steel in which higher strength levels are achieved by addition of moderate amount of alloying elements. What are the alloying elements? Titanium, vanadium, niobium in amount less than 0.1%. Usually you will find one question, what is high strength low alloy steels? Always remember, high strength low alloy steel has a alloying element less than 0.1%. They can be more sensitive to cracking during fabrication from hydrogen embrittlement. This is another one question. So high strength low alloy steel is sensitive to cracking from hydrogen embrittlement. Hydrogen embrittlement, when it happens? If you don't use a low hydrogen electrode, if you don't do the preheating, then hydrogen embrittlement can occur. Okay. Delayed cracking, also known as underbit cracking. Delayed cracking means it happens after the welding, not immediately after welding. After welding, after some time it happens. Low alloy steel, a family of steel containing 9% chromium and other alloying addition for high temperature strength and creep resistance. So this is another one questions. This is high strength low alloy steel. It is low alloy steel only. Okay. This contains 9% of chromium. The low alloy steel commonly encountered in refining including carbon 0.5 mole, manganese 0.5 mole, 1 com. This is the combination it is showing. Okay. These are considered ferritic steels, although their microstructure might be an alternation of the ferrite phase found in the carbon steel. Martensitic stainless steels, again 400 series, a family of stainless steel including 410, 416, 420, 440A, 440B and 440C. Nickel based, this is important. Usually I find these questions many times in the exam. A family of alloy containing nickel as a major alloying element, more than 30% of nickel. More than 30% of nickel is called nickel based alloys, including alloy 200, 400, K 500, 800, 800H and all this. Stainless steel, an alloy of iron with at least 10.5% of chromium plus other alloy addition depending on the specific grade. There are four major categories of stainless steel that are characterized by their metallurgical structures and room temperature: austenitic, ferritic, martensitic and duplex. Here it is not mentioned super duplex. There is another one grade also there, higher than duplex, we call it super duplex. So, atmospheric corrosion. What is atmospheric corrosion? Corrosion that occur from moisture associated with atmospheric condition. If the atmospheric condition is more industrial area, if you are if your plant is in a greenery area, if your plant is near to some good environment area, if your plant is near to some hazardous industrial area, so this happens with corrosion that occurs from moisture associated with atmospheric condition. If the atmospheric condition is more bad, then the moisture attached to that atmospheric condition. Let's say your plant is near to some chemical plant where the emission is too high. Let's say your plant is near to some power plant where the fossil fly ash is coming regularly. So those fly ash they can attach to the moisture because fly ash is very light. When it attaches to the moisture, it becomes heavy and it will fall on your stainless steel surface. Let's say on your equipment body, let's say your pump casings. So what will it happen? It will start corroded. So that depends upon which atmospheric condition your plant is there. Marine environment. This is the most dangerous environment actually. The most corrosion happen near to marine environment. Marine environments and most polluted industrial environment with airborne contamination are the most severe. So, marine environment and most polluted industrial environments with airborne contamination most severe. Dry rural environments cause very little corrosion. Where there is dryness, there is less humidity, okay, in the rural areas, that is less corrosive than compared to the industrial environment and marine environments. Affected materials: CS, carbon steel, low alloy steels and copper alloyed aluminums. Critical factors: the physical location of the plant. Critical factors, how it affects: where the location of the plant. The plant is in industrial area, marine area, urban area or rural area. As I told, rural areas are less effective, whereas industrial and marines are highly effective. Urban, we can make it as a 50-50. Okay, but the most one is industrial and marine and the least one is the rural. The amount of moisture, humidity, rainfall typically present in the presence of cooling tower mist. The presence of salts, sulfur, compound, dirt and other contamination in the air. This is important. You will find this as a question. Which one I highlight? These are important questions. So, Corrosion rate increase with temperature up to 120 degrees centigrade. This is very important. Corrosion rate increases up to 120 degrees centigrade. Above 120 degrees centigrade, surface are usually too dry for corrosion to occur except under insulation. So above temperature 250 F or 120 degrees C, the corrosion usually stops. Below to that temperature, usually corrosion happens. Why? Because the surface is dry. After 120 degrees centigrade, it happens. Possibility is there if there is a insulation. Okay. Marine environment can very corrosive. You have to remember this one. Very important this one. About 20 mpy. What is mpy? Mils per year. Okay. Mils. With 1000 mils 1 inch. We already did that. So marine environment can be very corrosive, about 20 mpy as per industrial environment that contains acids or sulfur compound that can form acid, about 5 mpy to 10 mpy. Island locations exposed to a moderate amount of precipitation or humidity are considered moderately corrosive environment, about 1 mpy to 3 mpy. These numbers you have to remember: 1 mpy to 3 mpy, 5 to 20, 5 to 10, about 20 mpy, and this temperature. This is usually come as a closed book questions in APA 653. Dry rural environment usually have very low corrosion rates as we read it. So rural environments having a corrosion rate less than 1 mpy. Affected units of equipment: unpainted, uninsulated carbon steel and low LS steel piping and equipment operating below 120 degrees centigrade where moisture can contact the surface is the most affected one. If any piping surface is unpainted or uninsulated, so it can come in direct contact with the moistures and can damage its surface. Uninsulated carbon and low LS steel equipments with deteriorated paint or coatings. If any paint or coating is deteriorated, then might be it can happen. Equipment downwind of cooling towers and wet gas scrubbers. Equipment may be susceptible if cycled between ambient and higher to lower operating temperatures. Prevention and mitigations. How we can do that? Paint or coatings are normally applied to otherwise unprotected equipments to prevent atmospheric corrosion. Surface preparation and proper coating application are critical for long-term protection in corrosive environments. Inspections, how we can do that? UT can include techniques like straight beam and angle beam. So if there is in corrosion, how much thickness of the corrosion material is damaged, that we can do by UT. Okay, ultrasonic testing. That is also with a straight beam or angle beam. UT also thickness restrictions. You cannot do UT on every thickness. Okay, less than 6 mm we cannot do UT. To directly measure the remaining wall thickness or screening technique using EMAT or GWT. So this is one type of corrosion. It is showing how it happens, atmospheric corrosion. Okay. So next corrosion is brittle fracture. Okay. How brittle fracture happens? Brittle fracture is a sudden rapid fracture under stress. Brittle fracture happens suddenly. Okay. Residual or applied, where the material exhibits little or no evidence of ductility or plastic deformations. So affected material, when I write all these things, these are the important things you have to remember. In exams, what they do, they will ask, brittle fracture happens to which type of materials? A, B, C, D, and you have to find something like that. Okay. So these are the questions. What I told, 8 to 10 questions will come. They will mention this material will happen in which material, this defects will happen in which materials. Then how you can do the prevention and mitigations, how it looks. Okay, all these aspects they will ask in questions. So affected material is CS. Low LS steels are the prime concerns, particularly older steels. 400 series SS are also susceptible even if not embrittled. In addition, materials susceptible to an embrittling mechanism such as sigma phase, embrittlement, 885 degree Fahrenheit to 470 degree Fahrenheit is embrittlement, temper embrittlement, straight grain. So these are the requirements which happens with the brittle fracture. You have to no need to remember this one. Just remember this. It happened to carbon steel, low LS steel for prime concern, particularly older steels, 400 series SS are also susceptible even if not embrittled. Okay, so this one you have to remember, affected materials for brittle fractures. So prevention, using fully killed steel. Fully killed steel means removal of oxygens. Okay, fine grain steels with austenitic grain size finer than 6 will be the remedies to avoid brittle fractures. So these are the requirement for brittle fractures. So inspection and monitoring, how will do the, see, it is a sudden rupture. It will never happen with 1 year or 2 year like that. This will happen suddenly. So inspection and monitoring, how will do? These are also questions. Inspection monitorings. Look, how will do the prevention and mitigations? It happens to which materials? These are the questions usually. Okay, 8 to 10 questions are coming from this one only. So routine inspection is not normally used to detect the mitigate brittle fracture, but awareness of susceptible requirements can help prevent future damage. Susceptible vessels can be inspected for pre-existing crack like fabrication flaws, as well as for cracking from relevant in-service cracking mechanism using the MPI, magnetic particle testing, PT and UT. Okay, these are the tests we can do it to find out the brittle fracture has happened or not. Then another one corrosion is coming, caustic corrosion. Okay, so caustic corrosion, how it happens? Localized corrosion due to concentration of caustic alkaline solutions such as sodium and potassium. Okay, sodium hydroxide and potassium hydroxide, and or corrosive salts from other solutions. Okay, so these are the, okay, so these are the reasons for which the caustic corrosion happens. Okay. So what are the affected materials for that one? Primarily carbon steel, low alloy steels, 400 series SS. Carbon steel is the material most commonly used in the suitable situations where caustic corrosion is a concern. 300 series SS is generally resistant to caustic corrosion until passivate is damaged. These are nothing to understand. As I told you from the beginning, you have to make a note on this one and you have to remind it. Okay, you have to remember all these things. There is nothing to understand on this one, which can occur in the approximate temperature between 160 to 200 degree Fahrenheit or 70 to 100 degrees centigrade. So these are the things which I have highlighted. You have to take a note on that one and keep on remembering. You will mention first caustic corrosion. What is the description of damage? This happened due to corrosion due to concentration of caustic alkalines. Okay, affected materials, what are the affected materials? It happens. Then affected units or equipments where it happens. Now localized caustic corrosion is most often associated with boilers and steam generations. So in question it will come, caustic corrosion is happened where? Boiler, steam generation, equipment including heat exchangers, pipings, pressure vessels. All these different options will come, and you have to select boilers and steam generating equipment including heat exchangers. So this is happened due to caustic corrosions. So how to prevent it? In steam generation equipment, caustic corrosion is best prevented through proper design. Caustic corrosion can be avoided by what? Proper design. This is a question. Okay, you cannot do with a change in material or something like that. Damage can be minimized by reducing the amount of free caustic by ensuring adequate water flooding and water flow. Okay, carbon steel have serious corrosion problem in high strength caustic corrosion. Caustic solution at elevated temperature. Alloy 400 and some other nickel based alloy exhibit much lower corrosion rates. How to do the inspection? UT using a straight beam and UT scanning with similar technique can measure the general loss. Localized corrosions, manual UT including UT scanning and AUT. AUT is acoustic ultrasonic test. Caustic stress, that is only caustic, here it is caustic stress. Caustic stress corrosion cracking is characterized by a surface initiated crack that occurs in piping and equipment exposed to caustic alkaline hydrogen solutions. Okay, affected materials. These are the important, as I told you. You have to remember what are the affected materials. Carbon steel, low alloy steels, 300 series SS are susceptible. Duplex stainless steel are also susceptible but have low improved resistance compared to the 300 series SS. Nickel based alloys are more resistance. Okay. Critical factors, what are the critical factors? Susceptible to caustic stress corrosion cracking in caustic soda and caustic potash. Okay, NaOH, caustic soda and caustic. I told caustic hydroxide, that is caustic soda. Okay, and caustic potash. Solution in a function of caustic strength and metal temperature and stress level. So these are the critical factors we have to do. This is important. Cracking can occur at, this usually come in the question. Last year I think this question came. Cracking can occur at low caustic level if a concentrating mechanism is present. In such cases, caustic concentration of 50 to 100 ppm are sufficient to cause cracking. So how to prevent? A heat treatment is required. For caustic stress corrosion cracking avoidment, we have to do a heat treatment, okay, PWST, up 620° minimum with a minimum holding time of 1 hour is considered an effective stress relieving heat treatment for carbon steels. 300 series SS offer little advantage in resistance to cracking over carbon steels. Nickel-based alloys are most resistant to cracking and may be required for high temperature and caustic concentration. However, caustic stress corrosion cracking of these alloys has been observed at high temperature that promote the formation of molten caustic in the absence of free water. Okay. Inspection. How will do it? The inspections? Angle beam is one of the PT, RT, AET. WFMT, SEFM, ECT can be effective techniques. So most of the techniques we can find out the cracking mechanism. So this is a curve which will come in the open book. Usually in the open book it comes, okay. Concentration of NOH, temperature, you have to find out application of which alloy you have to use, okay. What is the temperature range? Let's say the NOH concentration is 10, okay, and the temperature is 180° centigrade. Still you can use carbon steel, no stress relief is necessary. This will come in an open book, okay, must question. This will come in the open book, must question for caustic service chart, okay. They will give you the NOH concentration, okay. They will mention, let's say the NOH concentration is 20, okay. They will give temperature 240. And they will ask you which material will be suitable for this one. They'll put carbon steel stress relieved, nickel alloy. Okay, you have to choose nickel alloy because it is coming in the zone of area C. So this is a open book for APA 571. Chloride stress corrosion cracking. Surface initiated cracking of 300 series SS and some nickel based alloy under the combined action of tensile stress, temperature and aqueous chloride environment is the result of a chloride stress corrosion cracking. So this is the definition. Sometimes it comes in the exam. So affected material, what are the affected materials? All 300 series SS. Weld in 300 series SS normally contains some ferritic producing a duplex structure that is usually more resistant to chloride stress corrosion crackings. Duplex stainless steels, nickel based stainless steels. Critical factors. Chloride content, temperature, pH, tensile stress, presence of oxygen and alloy compositions are critical factors. Okay, so these are the critical factors which it happens. Although there are exceptions at lower temperature and even ambient temperature, particularly with highly cold work or sensitized materials, cracking usually occurs at metal temperature above about 140° centigrade F or 60° F. Okay, 60° C. So what are the affected materials? Most non-stress relieved 300 series SS pipings are the affected materials for chloride stress corrosion crackings. How to avoid it? Material of construction resistance to chloride stress corrosion cracking should be used. CS low alloy 400 series are not susceptible to chloride stress corrosion. We have to avoid that one. When hydrostatic, low chloride content water must be used. That you know. Usually for the stainless steel we use less than 50 ppm. Okay, for carbon steel less than 200 ppm chloride is used. If you want to know more about the hydrostatic testing procedures, how it happens, how we have to conduct a hydro test, I have a separate video on that one. I request you please go there and watch about that one. Okay. Inspection and monitoring, these are the requirements. I am not going into details. As I told you, you have to make a note of that one. Okay, how to do the inspection and testings. Then corrosion under insulation. This is very important. One question usually come from corrosion and under insulation. Must question. Corrosion under insulation you will get must one question. Corrosion of piping, pressure vessel and structural component resulting from water trapped under insulation or fireproofing. Some of the steam lines where the temperature we have to maintain, or the coolness we have to maintain, or the piping we have to protect, at that time we do the corrosion, or we do the insulation. So during the insulation, if some of the leak appears, or from outside there is some insulation leak and the water entrapped inside that one, then the corrosion can occur. So that is, affected materials are CS, low L steels, 300, 400 series and duplex stainless steels, almost all the materials. Okay, so what are the critical factors? Temperature, duration of wetting, design of the insulation system, insulation type and environment are the critical factors. So corrosion rates increase with increasing metal temperature up to the point where the water evaporates quickly, while water boil of steam above boiling point 212 degree F or 100 degree C, it does not do as instantaneously. It makes some amount of time for water to boil off and wet insulation to dry out. During this time the metal is corroding. Okay, so this is the reason. The question will come from here. Must question, as I told, very important. In most situations and as practical matter, refinery generally focus with CUI management effort on insulated carbon steels, low alloy steel, 400 series SS equipment operating between -12C to 175. So for carbon steels and 400 series, it is -12 to 175. For 300 series stainless steel, where the chloride stress corrosion cracking is the concern, is range from 60 degree centigrade to 175 degree centigrade. You have to remember the degree Fahrenheit and degree centigrade because they are confusing. Always the question is confusing for that one. Okay, so it is 10F to 350F, 140F to 350F, and it is 280F to 350F for duplex stainless steel. So please remember this one. This is a question, must question. So affected unit of equipment and insulated piping and equipment are susceptible to CUI under the condition noted above. Even piping and equipment where the insulation system appears to be good condition and no visual signs of corrosions are present. So these are the affected units. You have to go through it. I will not go one by one. Just make a note on that one. Okay, these are possible questions. Prevention, how you can do that? Since most construction materials used in the refining are susceptible to CUI damage, mitigation is best achieved by applying an appropriate coating or to the equipment prior to the insulation. So if this is the piping and you have to do the insulation on top of it, before doing the insulation you can put a coating layer on top of the pipe. So even though there is any ingressment of water from outside or there is leak from inside, the water will not damage the whole surface. A small surface will be damaged and we can find out it during our routine inspection. So inspection and monitoring, how will do that? Non-invasive commercially available method can be used to identify either wet insulation or CUI damage under the insulation without removing the insulations. However, this method should not be expected to find 100% of the damage. Each of these methods is discussed in API 583, including advantage and disadvantage of each. Usually what happens? The best way to find out the insulation damage is by visual inspection. There is very other types of inspections, like there is a neutron backscatter methods in which you can find it out, but I suggest the best one is to see whether there is a frequent visual inspection should be there. By this method you can find out. So this is one of the corrosion under insulation happen here in one of the piping. Okay, this is by visual inspection because these are the sections where it happens the most. These sections, okay, where the intersection is happening. So all these intersection areas, the the damage can happen. Mechanical fatigue, including vibration induced fatigues. Mechanical fatigue cracking is a mechanical form of degradation that occurs when a component is exposed to cyclic stress for an extended period. If a cyclic stress happens to a particular product for a long period of time, then the mechanical fatigue can occur. Okay, so these are the affected materials. All engineering alloys are subjected to mechanical fatigue, although the stress level of the number of cycles necessary to cause failure can vary by materials. Critical factors: geometry, stress level, number of cycles, material properties, strength, hardness and moisture. These are the requirements. So design factor: fatigue crack usually initiated on the surface at notches or stress risers under cyclic loadings. Affected unit or equipments: socket welds and small bore pipings associated with or near pumps, compressors and or other rotating and reciprocating equipment that are not properly guested or supported, that happens to the mechanical fatigue. Let's say one pipe is there. One pipe is supported with the support. Okay, so this support was not properly fixed and the pipe is continuously vibrating. So if it will vibrate and the support was not properly fixed, then this person might be affected with the mechanical fatigue. So inspections in high cycle fatigue, the time required for a crack initiated grow sufficiently to be identified by NDE, PT, MT, angle beam UT. These are the requirements. Okay. Another one type of defect is microbiological influenced corrosions. Corrosion caused by living organisms such as bacteria, algae, and fungi is the microbiological influenced corrosions. Okay. Affected materials are 300 series, 400 series SS, aluminum alloys, copper alloys, and some nickel alloys. Critical factors. Microbiologically influenced corrosion is found in aqueous environments. If the environment is aqueous, then the aqueous means more moisture is there. Okay, occasionally it is found in the surface where water is intermittently used. Microbiological influenced corrosion usually happen more in a desalination plants where there is more waters are used. Okay, because there are many types, organisms can survive and grow under a wide range of conditions including lack of oxygen, light up, dark, high salinity, pH range from 0 to 12 and temperature from 0 to 235 degree F. So that's are the regions. How to prevent it? Microbes require water to thrive. Systems that contain water, cooling water, storage tanks, etc. should be treated with biocides such as chlorine, bromine, ozone, ultraviolet lights, and other components. Okay, proper application of biocides will control but not eliminate the microbes. Inspections. This is all the visual inspections, and there are some PCR inspections are also there to find out whether the microbiological growth is happened or not. So these are some photos of the microbiological growth by which heavy pitings occur because they eat the metal surface on those areas due to the microbiological. Soil corrosions. The corrosion of metal from exposure of soil is referred to as soil corrosions. It happened to CS and cast iron and ductile iron. Usually stainless steel surfaces are protected from soil corrosions. So what are the critical factors? The severity of soil corrosion is determined by many factors including operating temperature, moisture and oxygen availability. And again it depends upon which type of soil it is there. More acidic soil will eat the material very fast. Okay. So these are some of the requirements it is mentioned. What are the critical factors it happens? Please go through this one. This is not so important. So prevention, soil corrosion of carbon steel can be minimized through the use of appropriate coatings and cathodic protections. I hope you know the cathodic protections, already we read it in 651. Okay. So along with specific backfill to prevent rock damage on the coatings, inspection and monitoring by UT and MFL. Okay. A closed interval of potential survey is also help. A pipe coating holiday survey is also help to find out the soil corrosion severity. Sour water corrosion, which is acidic in nature. Corrosion of steel due to acidic sour water containing H2S, hydrogen sulfide, and pH in between 4.5 to 7. Carbon dioxide may also be present as well as other acidic surfaces such as dissolved organic acids. So this can make the sour water corrosions. So what are the affected materials? CS, SS, copper alloys and nickel Bgas alloys. So critical factors are hydrogen sulfide concentration if it is high concentrate, pH as it is mentioned 4.5 to 7, temperature, velocity and oxygen concentrations. So how to prevent it? Sorry. Process monitoring and control are important for minimizing the effect of acidic sour water corrosion. Process parameters that typically should be monitored. Example, the water draws, the overhead circulation, the control it. These are not so important. UT scanning LRT can be identified. Permanently mounted thickness monitoring sensor can be used. Okay. Another one is sulfuric acid corrosions. Sulfuric acid promotes general and localized corrosion of carbon steel and other alloys. Carbon steel HZs may be experienced accelerated corrosions. HZ means heat affected zones. So affected materials are 316L, alloy 20 high silicon cast iron, high nickel cast irons, alloy B2 and alloy C26, 276. So critical factors are acid concentrations, temperature, alloy content, velocity, contaminations and presence of oxidizers. This is another one open book questions. Must it will come. These two open book questions, as I told you. First one I already explained to you. Second one is same. What is the presence of sulfuric acid and what is the temperature? Based on that, you will find out what will be the corrosion over 200 MPa, 50 to 200 MPa, 20 to 50 MPa and 5 to 10 MPa. It will ask you, let's say it is 75% sulfuric acid concentration is there and the temperature is 2 to 5. So you have to find it where it is coming. So it is coming here. So the corrosion rate will be from 50 to 200 mils. Okay, sulfuric acid corrosion rate chart for carbon steel. This is a must question come in the exam. Two open book question as I explained, this will come in the exam. You must know where you can find. That is the most important thing. The question will come, you will understand, but in which code? Okay, 571. 571 where it is there. You have to find out that one. Okay, you have to know that is sulfuric acid corrosion is asking. So I have to find out in sulfuric acid corrosion. It will take time. That's why the open book questions, they give more time, 3 hours 45 minutes. So this is the summary I mentioned here. You will go here, atmospheric corrosion, it is very small in size, might be you cannot read it. Or if you can ask, I can send you the Excel file, or you can make a similar Excel file. I propose you make similar Excel files. Okay, description of the damage, affected materials, critical factors, appearance and appearance, then how to prevent it and what are the inspections we have to do. Make one by one all the defects, damage mechanisms and write all these things. If you write by your own, I believe it will be better. This is made by myself, okay, but it is small in size, so it is maybe difficult in you have to study. Make one from your side and read it. It is easy to remember. So once you remember all this, easily you can get 8 to 10 questions, and that is a must. So thank you very much for watching this video. In the next topic will come for APA 575 and that will end our APA 653 journey. Thanks for your time. I appreciate for that, and thanks my subscribers and viewers. Please share this video with your friends. Ask them to subscribe to this channel. Give comments and likes. Okay. Thank you very much.